Hi, this is Lex, and welcome to the FinTech Blueprint. It's your podcast about fintech, decentralized finance, digital banking, investing, robo-advice, artificial intelligence, and all the other frontier technology that is transforming financial services. To get more content, like an illustrated transcript of this conversation in your inbox, subscribe at fintechblueprint.com. So without further delay, let's jump into today's episode. Hi, everybody, and welcome to today's conversation. I'm so excited and privileged to have with us today Dean Tribble, who is the CEO at Agoric. He is a technical genius and a longtime developer around blockchain, smart contracts, as well as a number of other technology initiatives. So I'm really excited to learn from him today, and welcome to the podcast, Dean.
Thank you so much for having me. I'm very excited to be here.
Let's start at the beginning and pry a little bit at your motivations, at your sort of professional DNA. You've had some very profound experiences. Could you maybe characterize the strands of your career? Like, what are the things that get you going? What are the things that you've tried to weave together?
I started looking at AI and robots back before, when AI and robots were barely a thing. And that kind of grew into software enabling things to happen that couldn't happen before. Software enabling people to be more effective, software enabling groups to cooperate, all that sort of thing. And so sort of the love of software enabling cooperation between people and amplifying our capabilities has, been driving me for, since the beginning, since back in the, early 80s.
So what were some of the foundational companies where you got your professional experience? I know that you've spent time at Microsoft, you've spent time building brokerage and information systems for Schwab. What are some of the early experiences for you that really stood out and where, robots in the 80s, weren't as developed a concept other than maybe Arnold Schwarzenegger's pecs, but what were some of the realities that you encountered?
So I started with AI, which was the Sherdlu thesis by Terry Winograd, which was that first, typing English in to figure out, move the red block into the blue box or something, right? And went up to Stanford and Park, and really it was Xerox PARC, where seeing the Smalltalk system, seeing, this first window mouse-based system, seeing software that had really high level of abstraction, where you could talk in terms of documents instead of, editing text files and tech and lots of low-level commands to lay things out. And so that was pretty formative. I went from there at Park into a group doing distributed systems, which is where I met actually my co-founder here at Agoric, Mark Miller, but doing large-scale distributed systems and thinking about how to do large-scale distributed systems in a secure way, in a scalable way, in a way that you could really have this model of independent software agents communicating with each other over large-scale systems. And that, the groundwork for that had been laid at Xerox PARC, and I just got immersed in that. And that just sort of held a fascination from then on.
What is a distributed system, and what were the early versions of that?
Well, the earliest version that, I experienced was ARPANET, which was the precursor to the internet. Now, there were some others before that, but basically it is a system with multiple computers communicating to accomplish some goal. So it might be a machine on my desktop and a machine on your desktop where, we can chat back and forth, and that's going to be a distributed system. Or it might be, large-scale time sharing or cloud systems that are doing jobs on my behalf that my phone as another computer talks to over a network to those machines in order to orchestrate activity.
How obvious was it to you, and how did it feel to see those seeds grow into the internet and the web and what we see now?
Some parts of it were, of course, very obvious, and some parts right now either, in some cases they're a step backwards or they are just incredibly similar, right? Chat, where you would just, open a chat to talk to someone and start typing back and forth at them, was something that was around before I was in software, because one of the things you observe out of that is any computer system you give people, they will figure out a way to talk to each other. That was actually one of those rules as people were starting to roll out workspace systems and games and any system under the sun. If there was a way for people to talk to each other, then they would. And so that hasn't changed a lot. It's gotten enhanced with emoticons, and now you can do sometimes better groups or threads or what have you. But that's one of those fundamental human experiences that computers amplify and enable, and it's a wonderful thing and will be a pervasive part of software going forward. But the other things that we could see were, like in the time sharing days, it was, okay, a company would have a job to do some accounting thing or do some analysis, and they would submit it and they would get back an answer, right? And, that might be hours later, and it was sort of this batch processing. And you could see as people moved from, I submit something and I eventually get notified, which still happens, with CI jobs today, with software development tasks to do large scale testing of software, for example. But you could see that happening, but everyone would continually want stuff to be more interactive. And so the design model at Xerox PARC, this is sort of what was inspiring was, imagine what computers will be like in 10 years, right? You can do projections. You could do projections with Moore's law. How fast would they be? How much graphical capacity would they have back when, graphical capacity was measured in 320 by 200 screen was a high-end, high-resolution screen. That model of seeing people would like more interactivity, people would like more visualization, you could project forward. And so what they did is they bought incredibly expensive machines, trying to model what would people have for cheap on their desktop in 10 years, and then they built software for that. And that was a big part of how they were visionary, was first realizing to do that, but then once you can do that, you've got this capacity at your fingertips. What are some obvious things to do? And each one of those obvious things to do in that new future environment were all very innovative. And so that was another element of inspiration is, innovate by going out to the edge of what people could do and then do something obvious, right? Do something that fixes a problem or addresses some interesting question or challenge. And the obvious answers will be innovation.
You got to see that first expansion of the web and kind of the DNA of the web, which was nobody knows if you're a dog on the internet, right? The sort of privacy, anonymity, forums, the explosion of peer-to-peer file sharing and sort of this anarchist spirit. And then, of course, it went in very different directions until I think a lot of the crypto movement reconnected and made those ideas fashionable again with new technology. What was your reflection on sort of the original ideas of the web and how they met reality? Like, was that surprising in any way, or was it obvious that things were going to get sidelined? Like, can you talk about that vision and those ideals and that futurism and kind of how it warped and changed?
Yeah, sure. So first, there was this notion, so there was the ARPANET. And the thing about the ARPANET was you couldn't do commercial activity on it. So after PARC, I went to Xanadu, Xanadu Hypertext Company. Xanadu is where hypertext was invented pre-web. And before I was there, right, that predated me, but it was to bring hypertext to the world. And it was doing so, it was a much richer hypertext than even what we have now because you could follow backlinks, right? You could look at a document and you could easily see what linked to a particular phrase in the document. And so fine-grained links instead of the very coarse-grained links we have right now would allow you to do new things. So that's still something that we'd like to see in the future. And at the time, right, computers were much, much slower and smaller than they are now. And so it required a lot of fancy algorithms and design and all that sort of stuff. And that took a long time. And then, we had software. This is where, I worked on the first production smart contract with a sister company called Amex, where again, it's, smart contracts, which show up later and show up sort of thematically in a lot of what I've worked on is software that enforces the terms of a contract-like arrangement between third parties, right? So chat, right? If if a service is providing chat for me to talk to you, where neither of us work at the service, there's in some sense, it's software providing a relationship between third parties. But as soon as that involves transfer of assets or money, so I'm asking you to consult for me, and if you submit over the internet a solution to the problem that I had, and the system will automatically take care of payment, noticing that you have have submitted a document to me. Well, now that's a contract-like arrangement that we informally made, and you could have software that enforced it. That was sort of one of the original ideas behind Amex, American Information Exchange, which was where that first production smart contract rolled out. And that, that was one of the models where this is awesome. This is really great. Clearly, there's going to be a lot of this in the future. And indeed, Nick Szabo, who coined the term smart contract, was one of the ones that pointed out all the features about why it was important and characterized what it means to be a smart contract. And the problem was you could not do that on the ARPANET because it was commercial. And so there was a lot of tension of getting from a non-commercial ARPANET to a commercial ARPANET. And hypertext had some of the same issue. But the thing that was novel and different about hypertext rolling out was what we referred to as the power of brute force, where we had all these fancy algorithms to be able to tell who is linked to this sentence in this document. And, then systems like Waze came along and Alta Vista and early search engines where they would just say, heck with it. I'm not going to manage that with a fancy algorithm. I'm just going to search. I'm going to search every document out there and find all the documents that point at this one. And so when you ask the question, who points at this, I can just tell you, right? And doing that with brute force search was one of those things where, wow, computers got faster really quickly and could suddenly do these things and sort of took people off guard as to what was possible. And so, the web evolved somewhat differently than people had envisioned before they'd realized just how powerful computers were going to be and what the impact would be on how you approach these things technically. So, never underestimate the power of just brute forcing something in software.
What about the ideas of privacy and identity, or the ideas of, internet money? What did that look like in the 90s, and how did that compare to the Stripes and the PayPals that we got?
So let's talk about those. They're quite separate, though there was some overlap. So in the late 80s, early 90s, part of how do you do a large-scale secure system, how do you do a large-scale distributed system, was clearly you needed privacy, clearly you needed authenticity, authentication and integrity, so that, if something's claiming to be a particular party, you would know it was a particular party. Or even at the simple level, if I'm accessing a website or accessing, an online service, do I know it is the service that I intended to access? And so that's been a part of, software systems for a long time. Now, something that people that didn't grow up back then sort of don't think about is, in the world of pre-internet, we had a lot more privacy than we have today, because by default, things weren't online. By default, a security breach at a computer center couldn't get very much information about you because most of your life simply wasn't online. And most of your communications were not in a durable forum that people will be able to look at in 40 years, right? And so, privacy was sort of a normal thing. And so as we were moving into this online world, there were evolving technologies for how do we preserve that? And how do we preserve the privacy that not just humans need, but businesses need? How do we preserve the authenticity that comes from my meeting you in person and shaking your hand, or for notaries, all those kinds of things? How do we make the equivalent institutions online have some of the properties that we were used to? And so, and this was, in tension with some of the literally, spy novel level activity of both corporate and international espionage that some of these privacy technologies interfere with. And so you ended up with, initiatives like the Clipper chip and attempts to restrict the export of RSA and, the RSA crypto algorithms and all that sort of thing. And so there were very much, there were some pretty grand stories and a lot of work there of people to get those core technologies available to us as individuals so we could retain our privacy as the world moves online. Man, that was, and some of that was regulatory, some of that was legislative, some of that was, people that, that were finding ways to map it into really being free speech. I can tell you about how RSA works and you can't stop me. And free speech really was a powerful tool to not just getting freedom of speech, but protecting our ability to protect our privacy through technology. And there was a lot of vision, there's sort of the cypherpunks movement was the core of that. And, a lot of that was out here, tied around Xanadu, tied around Amex, tied around this extended group of software and economists all working together of how do we enable that privacy? But partly it's if you're going to have people able to cooperate online, able to do business online, you've got to enable that privacy. You've got to enable that authentication so that you're doing, that you're not being defrauded by random people who are pretending to be a legitimate business.
So many fascinating points in there. And so this is a bit of a loaded question, but have you been satisfied or maybe surprised at all by the development of the law around the original issues that the movement was focused on? I think about like different concepts that could have used case law to protect data and privacy, right? Like if your data is literally hosted on a server that you run out of your house, and it's illegal to search your house without a warrant, you have some sort of protection around your data by availing yourself to centuries of black letter law. This is an idea I'm stealing from Evan Moglen, who teaches around these issues at Columbia and authored the Communist Manifesto, I think in 92, if I'm not wrong. But regardless, what's your view on whether the law has kept up with reality, whether it's been successful at that, and generally, what's the relationship between these like legal symptoms of society trying to figure out what to do versus what's actually going on?
So, to a first approximation, I think it has done fairly poorly from a law point of view. Some of it has been forced by simple technical reality of, people can encrypt. And it was a huge step forward when Let's Encrypt went out, which made it very easy for websites to be SSL. And so now that's sort of taken for granted just for clarity of the audience, that it's largely taken for granted that when you deploy a website, you will have HTTPS, which is secure HTTP, as the mechanism by which people access your site. And that actually took someone working really hard to enable that to happen, so that became the default, instead of the default being everything's in the clear and only a few sites would put a little bit of encryption on the page where you submitted credit card numbers. And so that was a huge step forward, but it was a technical step forward. It was not a regulatory step forward. In general, not just in the software world, but in the non-software world, our privacy continues to be eroded in terms of what they can do, right? It used to be like in that case of, if I have a server at my house, you had to serve me with a warrant to get information about me. Well, now because things are up on servers, then what'll happen, and by the way, when you serve me a warrant, then I have a chance to talk to my lawyer and get it, and push back and get it narrowed down to just what the warrant might be appropriately about if there's some business that I'm involved in or whatever, instead of them ransacking my house for everything. And, but in the case of online services, they serve a warrant. I, as a customer, never hear about it, and yet my data is now out there in some, case area that might end up disclosing it publicly, for example. And so this is just, this is not a great place to be. It's where we're at, and we continue to push to make it better and better. In some cases, from a simple privacy technology point of view. In some cases, there are, governments like Germany that are much, much more serious about individual privacy because they have more recent memories about the problems if you do not provide individual privacy. And so, we hold them up as standards and promulgate that. But it's one of those things where, this is an ongoing battle, and it waxes and wanes as people really realize that their rights have been compromised and try and push to get them back. I advocate that everyone pay attention to their rights across not just software systems, but in general, because again, the regulators or the governments tend to migrate in a direction of less and less respect for them, as expediency and pragmatism erodes those rights.
So let's switch gears and focus on, there's sort of, from the outside, maybe it's like a dead period between Web 1 and Web 3, right? Where some of the experiments end up going off the rails, or you have kind of natural monopolies and centralization happening as VC ramps up, and you have blitzscaling companies in payments and in trading and in brokerage and so on. And it's 20 years until we get to Bitcoin, despite having a view of that future from Szabó, as you've described. Can you talk about kind of what you were focused on during that period and sort of what parts of financial services you had touched? And then more generally, like, what was the vibe and the atmosphere during that period?
Sure. So, when I go back to that definition of smart contracts, software that's enforcing the terms of a contract-like arrangement between third parties. Nothing about that says blockchain, right? Blockchain was not a thing that we understood. That was an invention that came much later than the idea of smart contracts. To me, smart contracts is sort of the more core concept for the world, because you can do it where I've got my machine and you have your machine, and we're engaging in distributed protocols in order to engage in some, whether it's commerce or other kinds of cooperation, but some cooperation where there are actual rights involved. I will swap this digital work of art in exchange for 3 months subscription to your webcast, your podcast, right? And that could be an arrangement that gets made in software. There's no money changing hands. There's no banks involved. There's no nothing. But we might want software that enforces that exchange. So I can tell, I've got this thing that is a cookie that will get me into your podcast for 3 months. And so that is a fundamental idea that many of us now at Agoric, in different companies and in different places, we're working on the technology stacks for. So we had a company called Agorics, no relation, other than a lot of the basic ideas in the 90s, where we really worked on evolving that idea and what are the right abstractions so that programmers can safely, quickly put together, independent market components into rich market applications, right? So a reusable auction abstraction that you could plug in an extensible notion of what's a digital asset, so your auction could be across all those digital assets. And then the security infrastructure to be able to have a digital right that represents participation in an ongoing contract or access to a certain amount of bandwidth that the system could enforce that access to. And this led to, for example, a whole bunch of patents that are now all safely expired back in the 90s, and a bunch of design ideas and patterns that survive to this day in the smart contract architecture that Agoric, the company, is rolling out on the Agoric smart contract platform. And so there was a lot of idea development there, as well as a lot of application of these ideas to, how to design large-scale e-commerce infrastructure. So that's where, the first brokerage information system at Schwab, written in Java from client to server. This was, within the first year of Java rolling out. And sort of large-scale banking systems, looking at the financial system. So how do you take checks, which are, paper checks, which banks process 20 billion paper checks, pieces of paper every year in US banks for $30 trillion. How do you get that to come online and still preserve the legal category of checks, which is different from an electronic payment? And things like that were all specific bits of infrastructure that all fall into this same model of how do I enable people to be able to cooperate and people to be able to do business in a safe way, in their, on their own terms on large scale distributed systems.
I want to ask you a question. I don't know if it's even a question. You're welcome to reject it. We'll figure out the aftermath if you do. But you keep going to the concept of an abstraction, and it seems really important to you, and it seems like a very important concept generally in software development, but also in maybe more broadly information processing. And you had mentioned also that you were interested in AI and robotics. And as we watch things like ChatGPT and DALL-E get built, the thing that has changed with them is the data ingestion. Instead of being trained on a small data set and then a very large data set, it's being trained on a gigantic data set of the entire human knowledge. And instead of having a lot of layers and parameters, it has an indescribably large number of layers and parameters. And there's something to me that kind of aligns between this idea of like an abstraction or a pattern or a framework that you create as a like cognition or like a meta layer in building software and primitives, like layers in a neural network or in some sort of AI model. What do you do with that question?
Sure. So I'm glad you pointed out about the abstraction, because of course I focus a lot on how to enable developers to build things, and that's a key ingredient there. From a user's point of view, so let me talk about that a little bit, and then I'll come back to the AI question. From a user's point of view, right? I mean, a conversation is an abstraction as opposed to it being, words we're saying back and forth or, flapping of our tongues to make air move, right? The thing that we care about is the conversation, which is an invention that you and I have to articulate the back and forth conversation that we're having. In software, it's the same kind of thing. The idea of a window is just bits on a screen, but when we communicate a user model, the idea of a window being this thing that is created, at Xerox PARC we use the term reified, turned into a real object, or at least a real conceptual object, but only in software. It's a powerful way to help program, and it turns out it's also important to create those kinds of models and those kinds of abstractions in order to communicate with users and give them a real-world analogy or something they can hang their understanding on. And so when we talk about components and component models, often that's one of the things that you're organizing components and component models around so that you can have lots of bits and pieces that you can all plug together to build up some rich toolkit and be able to solve lots and lots of problems. So the idea of a digital write or an electronic write, as Mark Miller would phrase it, being a thing I can point to in software that will give me access to some facility and the authority to use it, right? That's comes out of secure operating system technology architecture and that sort of thing. But that idea, so I could have it be, the rights to display an image or the rights to play a movie or the rights to an offline thing, which is a freight shipping. And so this abstraction is a bill of lading that represents what are the goods that are being shipped. All those kinds of things are abstractions that humans create in order to design and describe and build a more usable system. And so giving more power to do that leads to both more powerful systems, more extensible systems, but also in the future, more usable systems. With respect to AI, 5 years ago, AI was just, neural networks that were doing, that were trying to do something like one layer of the brain, and they could do some pretty amazing stuff, but it was all very focused. ChatGPT is an example of a next generation of that neural network stuff, where they are now realizing and starting to dig into that these multi-layer systems are actually creating abstractions in their weights where they're starting to go, what is this second layer thing that it is using or that is emerged out of the training data as it has applied this training process to all of this data. And they are starting to learn that indeed it looks an awful lot like various kinds of abstractions that humans evolve. And there really is going to be another generation or two there of very interesting improvement in AI growing out of understanding and analysis and enhancement of that, enabling of abstractions in software systems. So very excited about that.
Let's transfer over to Agoric now and Web3 and what you're building. And just to anchor us a bit, we've moved from the internet and the ability to have money on the internet to the ability to have computation on blockchains. And there's the Ethereum ecosystem and everything that's EVM compatible. But then there are other ecosystems as well that use different programming languages, whether that's Cosmos or Solana or Move with Aptos and so on. Can you talk about Agoric, what it does, and then where are you placed relative to these ecosystems and kind of what are you focused on?
So first off, let me go back. Again, I always start with smart contracts, right? Bitcoin was a smart contract in that it was software that enforced the terms of a contract-like arrangement of transferring money around and verifying that you could get it and all that sort of thing. What Ethereum brought to the table was that third parties could submit smart contracts to run on Ethereum. So it was an extensible platform for it. But the big thing that blockchain brings is not smart contracts, because that predates it and was, and if you look at smart contract businesses of eBay and PayPal and Venmo and Airbnb and Uber and Lyft and much of Amazon, those are all smart contract businesses where a service in the middle orchestrates, cooperation between independent third parties. But what blockchain brings is, sort of the gold standard is multiple machines in different jurisdictions and different organizations, all cooperating and coming to consensus about what happened. What data you have. Did Dean win the auction or withdraw his bid? You can only have one. Make a choice and have hundreds of machines in multiple places agree on that choice. And that's sort of the foundations of blockchain. Is that agreement means that no human organization or even government, any regime, can compromise the integrity of execution. So now you've got the ability to execute smart contracts with a level of integrity that was not possible before blockchain came out. That's the huge value point that blockchains bring, and that nothing else has. Nothing else in software that predates that brings that level of integrity. And that's something that, when we're looking at, well, does blockchain help this? Does integrity matter for this? How much does integrity matter for this? Or am I just going to trust, AWS to not do the wrong thing with my data, or Enron to not slip in electrical trades, if people remember the Enron debacle?
Or Wells Fargo to not open 1.3 million fake accounts for their customers and then charge them for it, right?
Yes. All those kinds of things that you would like a high integrity subsystem to at least make it obvious and clear what's going on, so people can hopefully prevent it before the fact and definitely find it after the fact and unwind. So now the question is, you want the ability to do smart contracts in this kind of high integrity infrastructure. How do you do that? Well, Ethereum, it was great that it brought this out, right? In the same way that, Flash brought out programmability on the web in some very important ways. But it does have some non-trivial limitations.
Love it. I love it. I just discovered that Flash no longer renders in the browser, I think was...
Yeah, well, the analogy actually with Flash is pretty strong in that it was a huge success. Now, Flash didn't have to fall by the wayside. There were, but it had, ironically, exactly the same intrinsic issues and intrinsic flaws that Solidity has, which is it had native reentrancy, which has led to, $9 billion in losses or thereabouts on Ethereum. And it has what I refer to as the message.sender security model, where the way security happens is I check, okay, this operation could be invoked by anybody. Anyone could invoke an operation on Dean's account, and I'm just going to check to see whether the person doing it is authenticated as Dean. And that's a easy to understand security model that could well be a non-trivial contributor to Ethereum's initial success, to which all of us owe a great deal. But it is something that in complex systems, it really interferes with composition. And it's basically something that humans are pretty terrible at figuring out the security consequences of. And thus you have a lot of security hazards that result from those two insurmountably intrinsic elements of the Ethereum architecture. And again, they might have been responsible for its early success, right? They make simple things simple, but complex things, effectively impossible to understand. And so there's a limitation, now, unlike Flash, right, where, once there were better models and people migrated to them, it just kind of went by the wayside. With Ethereum, we spent, as I said, billions of dollars hardening a few key smart contracts that now have, tens or hundreds of billions of dollars in assets in them. No reason to abandon those. Those assets are valuable. The liquidity is valuable, and you can connect to that with lots of other systems. But nonetheless, if you want to do innovation, you really, going forward, to get more than a few thousand developers that are able to build this stuff, you need a different approach. You need a different architecture that humans can actually manage. So that's sort of the background. That is why there's a bunch of additional projects out there to have a better way of programming smart contracts that more developers can succeed at better. Because migration to Web3, it's not going to happen with a few thousand developers. You need millions of developers, and the only way to do that is to meet them where they're at and give them a model that they can understand and succeed at. And so that's where we come in, right? And there's a lot of other models, a lot of other people building things that are solving either scalability problems, which are important, but from my perspective, that's just engineering, right? I mean, we've scaled lots and lots of systems collectively as an engineering discipline, from databases to web servers to chat systems and everything else, and from, small to billions of users. We know how to do that. It costs money. It's got to be done. Someone's going to do it, and there are people out there doing it. But the hardest thing to scale is the programmer base, and that's the focus of Agoric. So,
How do you do that? And then let's talk about also, the Cosmos ecosystem and what does it mean to be multi-chain and what's the protocol that you're building, like all of that.
And I'll tie those two together, right? The vision that we had back in the 90s, remember I said we worked on the smart contract models for large-scale distributed systems in the 90s. The vision of software in this, back to what's a distributed system, was of independent sovereign systems. My computer acting on my behalf, your computer acting on your behalf, some third-party computer acting as a trusted intermediary for you and I to complete a, escrow deal for a house or whatever it is, right? That model of independent sovereign systems cooperating using secure protocols to accomplish complex exchange interactions or complex market interactions, that was something that we've worked on literally for decades. And that's, and so that's our model of the world. From that point of view, blockchains are simply computers made out of agreement among hundreds of machines in multiple jurisdictions, et cetera, but they're built out of agreement rather than around silicon, right? Ethereum is a computer that runs about as fast as a smartphone, right? And it does a vast amounts of commerce running as fast as a smartphone, but with an integrity that, again, as I said, is beyond anything that existed prior to Bitcoin and Ethereum, right? But it's just one machine, and it can talk using those same secure protocols to other, quote, machines, which might be other blockchains or just, my phone or a server in the cloud or what have you. And it can use secure protocols so that we get to do, things that are appropriate are running on the blockchain, things that are appropriate for running in my private data center, run in my private data center, and I've got a uniform fabric of compute about doing commerce that spans both of those, right? And that's been our vision for a long time. Now that turns out, and we didn't find out until after we were already working with Cosmos. Cosmos is another crypto ecosystem, right? So there's Ethereum, there's Cosmos, there's Polkadot, there's Solana, there's all these different things. Cosmos was inspired by that vision, right? Mark Miller, my co-founder, ran a website that accumulated a lot of these ideas and helped evolve and design them in the open, the Elang website. And the Cosmos folk, when they were putting together this vision, Zucky and Ethan and Jay, when they were putting together how they were going to approach this, Zucky stumbled upon this website, and it's like, yes, this is clearly the vision. This is how this resonates with how we're thinking about it. We're building this piece. We can do IBC, Inter-Blockchain Communication Protocol, which is that notion of secure messaging between these different blockchain machines, and that will just work. That will solve the scalability problem. That will give us the sovereign machines, sovereign independent blockchains all communicating with each other in a way that is much more loosely coupled than any of the visions out of, coming out of rollups for Ethereum or Polkadot's, single sort of hierarchical cooperative chain thing. And so that was how Cosmos got started, as this vision of an ecosystem of these independent sovereign chains all voluntarily cooperating to accomplish larger economic activity. So when we went out and looking for technology, we tried several of them. We stumbled upon this, and it just, all fit and resonated. So what Agoric is building is a blockchain built using Cosmos SDK, so built using the proof of stake. Cosmos was the original proof of stake blockchain. So proof of stake on the Cosmos consensus algorithm, and for doing programming in hardened JavaScript, right? So in a language that 15 million programmers know, with a familiar programming model so we can meet them where they're at, so that instead of just, as I said, a few thousand developers, we can get towards a few million developers building smart contracts to really, sort of change the world with this stuff.
So when Agoric says, composable DeFi is here are your DeFi Legos, figure it out, put it together. What it means is that these are the DeFi primitives, but in your language and in a language you already understand. What's the magic? Like, what's the translation mechanism? What are the hardened primitives that you're providing? Like, how is it all tied together?
Mm-hmm. So let me back up just a tiny bit, right, to JavaScript on the web, right? JavaScript was in browsers, thank you, Brendan Eich, right, and pervasive for quite a long time. And there were libraries, these abstractions, that experts could use to build fancy user interfaces, right? And indeed, JavaScript already controlled, hundreds of billions or trillions of dollars every day through things like brokerage terminals and, the Bloombergs and Schwabs and everything else in the world. But then React.js and Vue.js and, a few other web components came out, which were very much focused on how do we have, as I said, it was a framework with graphical components for building applications so that, I could easily build a component and I say, here's how it renders, here's what happens when I click on it. And more importantly, had a framework for plugging those components together so that developers could use components safely provided by third parties, plug them together into a rich application. And then the net result of that is non-expert developers could combine components built by experts, right? You could have an entire spectrum of expertise to be able to plug together applications. So an artist could grab a slideshow for showing images and sliding through them and so forth, and a purchasing component for doing credit card purchasing, plug them together and deploy an application, even though they could not have implemented the credit card piece or the nice infinite scroll slideshow, and yet they can plug them all together and launch an application very quickly. And the net result was, 6 months after React, relative amateurs could build a more responsive, more internationalizable, more mobile friendly, prettier, sexier, more graphically, easier to use, etc. application than experts could the year before, simply because they could take these components and plug them together in a coherent way. And so it wasn't just JavaScript, but JavaScript has this ability to have this kind of component model, which is not true of most programming languages, including, for example, Solidity, such that you can now have a component model, you could plug third-party components together into a rich application. So it's the language plus the framework and component model. And so what Agoric has is the language, which we are on the JavaScript Standards Committee and we're experts at and so forth. But the language plus a framework and component model where instead of it being directed at mouse clicks and rendering, it is directed at, asset transfer and exchange and pricing and the kinds of things you need for building an interesting smart contract kind of application or business or component that someone else could reuse. So that's where we end up with what we refer to as DeFi Legos. It's these components in this component framework such that I can grab an auction Lego and it's got a governance hook. So I'm going to grab that particular way of governing it and I'm going to plug those two together. And I didn't have to implement either auctions or governance, but now I got to say, okay, I'm governed by, a committee of, 5 out of 7 and they're allowed to do these 3 things. And here's the auction and it's a Dutch auction instead of an English auction. And here's the minimum price and go, right? And so that ability to grab and plug together pieces in order or build up your application from pieces that other people built is, literally what gives you the ability to grow an exponential curve of applications and developers, right? It means that every bit of development that people do and publish becomes reusable by other people to, it raises the level of the world on which they're building such that they're building on yet one more abstraction, right? Someone does an NFT abstraction and now I can do NFTs, or I can take their abstraction and have, this idea of an NFT and make it so that I can have sub NFTs that are partial credit for it. And we all are going to vote using this governance abstraction to decide how or whether or when to sell the core NFT, right? And so now I've made a new application that the next person who wants to leverage that, they can focus on their comparative difference, their comparative advantage, and just leverage the component that I built to do, fractional ownership of NFTs. And so you start to build these abstractions to be much, much more reusable and pluggable than you can in any other language that people have contemplated on blockchain.
That's fascinating stuff. And so profound. For me, kind of the things that really resonate is the story about identifying abstractions and frameworks and that they are composable and that this is really like a repeatable pattern, like you're reformatting things. And where we are in the development of all this stuff is that what we're reformatting is socioeconomics, like we're reformatting social relationships between people, governance, their exchange. We're uploading our society, but bottoms up from its atoms. And so I think this is absolutely fascinating and impactful work. Let me ask you for our audience, if they want to find you on social media or elsewhere, and if they want to learn more about Agoric, where should they go?
So definitely, the Agoric website, of course, agoric.com, at Agoric on Twitter, and at Dean Tribble on Twitter, though I admit I need to post more technical stuff. But definitely those are the starting places. The other thing is, so we have rolled out the platform, but focused initially on the core market abstractions to provide sort of the basis of an economy running on chain. So that as people start to roll out businesses, they roll out in a rich economy. And so the first use case is Interprotocol, IST. And so you can find that at Inter.trade, INTER.trade, TRADE. And that is the stable token and the smart contracts to enable a stable token built in hardened JavaScript. And all those smart contracts, they're open source. They're all reusable for people to build their own applications. And as we start opening up the platform for third-party applications later this year, some of them will be using those components, or reusing those components, should I say. It's great sort of validation of the model. It's a great source of inspiration, and it'll be a great tool for third parties to build their own applications.
Awesome. Dean, thank you for such a visionary conversation and for spending time with us today.
Thank you so much for having me. We went places that I don't usually go in a podcast. This is great.
Hi, everyone. That's it for this week's episode of the FinTech Blueprint. For more technical deep dives into all things fintech and decentralized finance, check out fintechblueprint.com and grab a free subscription to the newsletter. This is Lex, and I'll see you next time.